Hello everyone and welcome to this new lecture. In this lecture, we are going to perform a little bit of deep dive into machine learning. So let's take a look at the big picture. So as I mentioned in the previous lecture, is that artificial intelligence is the kind of the big umbrella, kind of the father, the godfather of basically all the machine learning and deep learning and so on. So artificial intelligence is a science that enables computers to mimic human intelligence, and subfields within it are machine learning, robotics, and computer vision. And within AI, within artificial intelligence, there is machine learning, which is a subset of AI that enables machines to improve at a given task with experience. And again, the word experience is the most important word when it comes to machine learning. So you have, as you feed in the algorithm more data, as it grows, it learns from experience, it becomes better and better at the task every single day. So within machine learning, there are three different categories basically of learning, and that's very important. The first one is what we call it supervised learning. And these are training algorithms mainly that rely on labeled input and output data. Simply put, you have, let's say, a bunch of images and you have the true label for these images. For example, this image is an image of a cat and the label is a cat. This image is a dog and the label is a dog, and you keep doing that basically in a supervised fashion. Okay, so that's the first category. And within supervised learning, simply, there are two kind of classes, two categories within it. There's classification, which is what I've just mentioned, and there is regression. And the difference between classification and regression is that regression is mainly used when the output that I'm trying to predict is continuous output. So when the output is continuous, then we are going to use a regression. For example, I wanted to, let's say, predict the stock price, for example, tomorrow. Or let's say I wanted to predict, for example, let's say the temperature, for example, tomorrow. If the output value that I'm trying to predict is continuous, then we're going to use regression. All right, so that's it for supervised learning. The other category is what we call it unsupervised learning. And these are training algorithms with no labeled data at all. So all what I have is just a bunch of inputs. I have simply a bunch of images. And the machine or the technique, basically the algorithm, just you feed in these images, and the network will learn on its own. So there is no target class, there is no label. And that's again pretty scary and pretty fascinating at the same time. So what happened is, category basically within unsupervised learning is what we call clustering. And the idea is that when you feed in these images, the algorithm on its own will start to perform clustering. We'll say, okay, maybe these features mean something, maybe these other features mean something, and so on. And we don't have any kind of frame of reference, or what we call it ground truth, to compare the output of the unsupervised learning to. So in supervised learning, we have something, we have a class, we have a ground truth that we can assess the performance of our algorithm to. However, for unsupervised learning, I don't know. You just feed in the images and you hope the algorithm will work, basically. And the last category is what we call it reinforcement learning. And that's basically an algorithm that take actions to maximize cumulative reward. So basically, I'm going to show you exactly an example of this, but think of it as having a score, and the network, as it learns, is trying to maximize this score. That's all what it is. All right, let's dig a little bit deeper into these categories. So let's start with our supervised learning, and let's take a look at an example. So basically here, we have a data set that's a very famous data set called the fashion data set. You basically have a bunch of images, let's say an image of a sneaker, for example. And here I have my desired output, or my target class, or my label is a sneaker here. And when you feed in another image, again, that's an input, let's say an ankle boot, the class here will be an ankle boot. And here if you feed in a t-shirt, then the class will be t-shirt. And then you feed in, let's say, a bag, and the class here will be a bag. And as you guys can see here, what you do is that you feed in these input data or input images, and you feed in these desired classes or target classes or labels, and you feed in all these inputs and outputs in a supervised fashion. So you feed this data to the model, and the model starts to learn from basically these two input-output data sets. And what's good about supervised learning here is that the performance of the network could be assessed by comparing the trained model predictions versus my real output. All right, the next category is what we call it unsupervised learning. And an unsupervised learning simply provides the algorithm with no labeled data. So I don't have labels, I just have a bunch of inputs. So that's an example of a bunch of inputs, and you feed in all that data to my model, and the model learns by dividing this data into a bunch of clusters. We'll say, for example, like this, for example, let's say cross here will be grouped together. Here we have, let's say, all these blue rectangles will be grouped together. Here we have, let's say, green circles grouped together. And here we have, let's say, these stars, red stars grouped together. So that's what the algorithm does. The algorithm will attempt at discovering hidden patterns within our training data. And unsupervised learning methods simply can analyze complex data that humans might find it difficult to interpret. And again, one of the drawbacks of unsupervised learning is that there is no feedback. You just feed in the images, feed in the data, and that's it. I don't know if this data clustering technique was actually good or not, because I don't have a ground truth to compare it to. All right, and the last category of all is what we call reinforcement learning. And reinforcement learning simply allows machines to take actions to maximize cumulative reward. Think of it as a trial and error through what we call a reward and penalty. Again, I really like this example. In general, from a very high level, is that you have an agent and you have an environment. In our example, I have, let's say, a kid, okay, and that kid is contained within, let's say, a room, okay? And what you do is that the agent performs some actions or takes some action in the environment. For example, here in our example, the kid will, let's say, start to explore the room, basically. Will start to, let's say, for example, touch, for example, let's say the bottle of milk, for example, or let's say touches, for example, let's say a candle here. So these are the actions that the agent will take on the environment. And what happened is the environment will reply back to it. Okay, that's again what happened in real world. What happened is that if the kid, for example, let's say touches, let's say the milk bottle, he will get positive points. Will get, let's say, 10 points plus. And if he touches, let's say, the candle, he will get hurt, and then he will be penalized. So he will be minus 10 points subtracted, basically. And that's the overall idea of cumulative reward. The agent in the environment will try to, through trial and error, try to maximize basically the cumulative reward, and based on that reward and penalty, the agent will improve its environment knowledge and start to make better and better decisions moving forward. All right? Okay, and that's the overall idea of reinforcement learning, and that will conclude our lecture. And that's all what I have for this lecture. I hope you guys enjoyed it, and please enjoy TensorFlow 2.0 Practical Advanced, and I will see you guys in the next lecture.